Hello. Yeah. Good afternoon. We have a series of lightning talks. There are 4 on the agenda, but now we have a 5th one because they're lightning. And hopefully we'll have time at the end. So please feel free to present your own. That's the whole point of the lightning talks, that something you may not have fully fleshed out, you can mention here. Somebody else in the audience may say, I would like to work with you, and next time we'll see you here with a full-fledged presentation. So please treat this slightly more informally. Feel free to come talk about whatever you're interested in. You might find that actually there's somebody else in the audience who's also interested in it. We have a good, varied lineup. We have APNIC Fellows, the fellowship program. If you're not aware of it, please go look up, encourage people you're mentoring or yourself. Please, it provides bursaries for you to come to Apricot and APNIC. First up, we have Mr. Carlos, I'm not sure, from Delft. You're still with Delft University? Oh, he's gone over to the admin guys who control the internet. So speaking from the HQ of the internet.
Thank you for the introduction. So good afternoon, everybody. My name is Carlos Gagnan. My surname is hard to pronounce, so I guess that's why the chair avoided. So I work for ICANN, for the Office of the CTO, and particularly in the Security, Stability, and Resilience Research team. So what I'm going to share with you today is basically an update of the different measurements that we are doing regarding the registration data access protocol. So for the ones that are actually not aware of what I mean by registration data basically is used in daily life for different types of businesses. Here you have a couple of examples for law enforcement when they want to identify which type of who is behind a particular domain name, or even with the IP addresses, who has registered, who's the owner. So from law enforcement, but also researchers use registration domain data. So in the 80s, so accessing, actually registration data is not new, right? So this was created around the 80s. The de facto protocol was WHOIS. So it was really simple response text protocol. You run a query, who is the owner of this domain, and then you get the data. However, WHOIS has all kinds of issues, right? It has issues regarding security, doesn't provide any kind of integrity, doesn't provide authentication. So WHOIS is really simple. So the community started to think of new alternatives to actually access registration data. And it was around 2015 when the IETF actually decided to create a new protocol. So they standardized the RDAP protocol, the Registration Data Access Protocol. And here what you can see in the slide is basically on the left, the traffic flow of accessing to the registration data of a particular domain name via the WHOIS protocol, and on the right, accessing the registration data using the new protocol, the RDAP protocol. And you don't need to be an expert to see that there are way many more here data packets that are being exchanged when using RDAP versus when you are using WHOIS. So the research that we were conducting within Octo was basically to see, okay, RDAP does provide security, it does provide an more standardized output format, but it comes at a cost, right? If you just look at the response time of the same type of domain that you want to get registration data, and you compare it, it's a bit slower. So we already conducted a study in 2021, and we wanted to update it with the new kind of RDAP services that were deployed. And here we have different research questions, right? So the main research question was actually to see which are the factors that influence the response time of the different RDAP services. And we also wanted to know not only the response time, but whether the response, the output of the query actually was conformed with the different RFCs that actually define RDAP. So in order to answer those research questions, we had a really simple methodology. First, obviously, we have to create a set of queries, right? So we want to measure how fast you can retrieve data, then you need to run queries. And in order to create these queries, we basically sample 100 objects, depending on the type of RDAP services. These 100 randomly selected objects could be domain names, could be AS numbers, could be IP addresses. And here you have 3 different kind of data flows on how to create these queries, depending on the operator of the RDAP service, right? So in the first one, you have the RIRs, second one, you have the GTLDs, and then you have the registrar. Once we have the queries, we have to run them, right? And in order to avoid potential biases of the geolocation from which the query is run, we use 10 different vantage points, and we run 1 month of measurements. So every 5 minutes, we run the different 100 queries that we created for each one of the operators. And for each query, we actually measure the response time and also store the data. Finally, as I mentioned before, we also kind of computed whether the output was conformed with the different RFCs. Here you see that there are 4 RFCs that are defining how the data, the output of the data should look like. And ICANN has made this tool available for everybody so that you can check whether, if you are running an RDAP server, whether your output actually conforms with the specifications of the RFCs. So just jump into the results, right? What we saw is basically the landscape didn't change that much from 2020 to 2021. We did have a bit more of deployment. So there are 90 new registrars that were actually deploying their own RDAP services. The response time was slightly increased, but not significantly. And that's basically because, as you can see here in the CDF, so basically this represents the average response time, and you can see here like a ratio. So basically below 4 seconds, 90% of, almost 99% of all the services. So all the queries were answered below 4 seconds, right? And if you just compare the curves, what you see is like the RIRs actually are the faster. So the 4 RIRs are the ones that provide RDAP services that are the fastest, followed by GTLDs, and registrars are the ones that are a bit slower. It's also nice, well, not really nice to notice, but they're outliers, right? So it means that the services provided by these registrars can take up to 8 seconds on average to retrieve the information. That means that if you run a query, like I said before, give me the information for this domain name, you can be waiting 8 seconds. We also compare whether there were differences regarding the type of object that you wanted to retrieve registration data, right? So we compare IP addresses versus AS numbers versus domains. And you can see that in the median here, IP addresses was a bit, well, not significantly larger, but it was a bit higher, the response time, than if you just do AS or domain names. But you can also see that there is a huge variance, right? So that's why it's not significantly different, just because depending on the service, the time that it can take to retrieve that information, it can vary quite a lot. We also measure whether there could be differences in terms of the transport layer security that the different services were accepting. And this was a bit surprising, right? So we are in 2022 and we still have servers that are using SSL. So SSL is well known to have all kinds of vulnerabilities. And this is concerning because they can launch, well, basically man-in-the-middle attacks that are not that hard to formulate nowadays. So in the end, because our aim was basically to see if we could see difference depending on the TLS. TLS 1.3 reduces the runtime time, so it's a bit faster, basically because by design it reduces one runtime time, but only 15% of the RDAP service actually support TLS 1.3. So here, basically, you can see that the deployment on TLS 1.3 is not really that high when it comes to RDAP servers. And we have an issue when it comes to SSL, right? Because if you have servers that only accept SSL2 or SSL3 or TLS, those are not really secure servers. Finally, as I mentioned before, we also measure whether the output conformed with the RFCs, with the standards. And basically what we see is like there is a minority that did not, but the majority did. Most of the issues were basically regarding the vCard array and the JSON. So RDAP output is really standardized. So there is a lot of checks that you have to do in order to be sure that the output that you are actually giving as an answer fulfills all the requirements of the RFCs. As I mentioned before, we have a tool that allows you to do that check automatically. And here you have the different codes, error codes. So the most important part is like this was actually a minority. So just to conclude, in the update that we had from 2020 to 2021, the RDAP services that were deployed were following the same line in terms of response time. So there were no major updates in terms of performance. However, we did see that a minority of the services did have some security issues regarding to the protocol, the TLS protocol that they would accept. And of course, we also measured in this new update that the output was mostly conformed with the RFCs. So that was all of it in my super lightning talk. I'm not sure there is the space for questions because you put.
Just introduce yourself.
Hi, my name is Etuate. I'm an APNIC community trainer. So my question is regarding the vulnerabilities that you mentioned on the TLS. What sort of vulnerabilities are we referring to? For SSL?
Yeah, so in theory, SSL is deprecated.
Yeah,
so
yeah.
No server should allow that type of, so when you have to agree, right? In the client service communication, you have to agree which SSL or TLS protocol you are going to use and the cipher, right? So what we saw is like there are certain RDAP services that only allowed the deprecated services that are vulnerable. So that's the main issue. It's not that they allow those and also TLS 1.3, it's just they only allow the ones that have huge issues, right? That doesn't mean that they are being exploited because we didn't measure that, but does mean that it could happen, right? And there are all kinds of tools to do that. So it's not like it's a really complex attack because you can just, it's a really old attack. Actually, I think it has more than 10 years old, this type of man-in-the-middle attack where you can sit, between the exchange of packages. So it was concerning.
So that takes me to the next question is the fact that you have identified all of this and, in reality, that's the way it is. People still prefer the old method because it works. Why change? Even though we already broadcasted, it's vulnerable. What can I can do more for things like this?
Yeah, so we have the whole compliance department actually reaching out, trying to encourage the deployment of actually and use of TLS 1.3 just because it's faster and it's more secure, right? So it's not really complex. It's just that, people don't have time. So there are all kinds of incentives there to actually deploy one thing or the other. But in the end, it comes down to the fact that registration data is also public, right? So even if you have a data breach, it's a data breach of data that in theory is publicly accessible. So then the incentives to actually deploy a secure, a transport layer protocol are really not aligned.
So, but do you do reach out to those?
Yeah. So our compliance department is reaching out because I think it's just good practice, right? Even if the data is publicly available, you don't want that data to be in the hands of somebody that is not supposed to have it, right?
Cool. Thanks.
Thanks, Carlos. Please feel free to catch him outside and continue the conversation. Mr. Anand Raje, he's with the Internet Research Association in India, and over the last 2 years, they've been building a network of monitoring probes throughout India to see how do end users see latency in the first case and also other aspects. Anand.
Yeah. Hello, everybody. I have slides. Okay. Yeah, thank you. So thanks for the opportunity for the lightning talk. And this is about a measurement project that we were developing from last 2 years as part of Advanced Internet Operations Research in India project. This is a holistic platform that we wanted to build. And there are platforms right now, RIPE Atlas, KAIDA, and other platforms available. And before me, there was a presentation on measurement. So we had some perspectives, and the perspective was for DNS and routing. And we wanted that a platform which could be protocol agnostic, and we can build anything from that, and community could be involved in this kind of project. So this is about the project wherein we have kind of built an infrastructure which is having an Anycast DNS installations, Anycast servers, and anchors which are capable of measuring the protocol parameters. Why we are here? Because the platform has been developed. It has taken around 2 years of time and it is running right now. If you search AIORI.in in your mobile phones, you will get where from you are actually being served. And this AIORI.in is in 5 locations across India. So maybe the community behind it, and there are community feedbacks that we wanted, that how to grow this network and how to work around this. So as an ISP, system admin, researcher, user, enterprise network, everybody wants to measure internet protocol parameters. So an open source environment wherein anybody can collaborate on that in the making of it, very intuitive, and academia and other stakeholders could also bring value to it. That was the main motive. So where we are right now, this particular measurement platform, we are having 5 LRoot Anycast instances hosted in 5 locations, around 5 Anycast instances, which is having the DNS authoritative zone, recursive servers, and the AIORI wave interface, which we use for measurement. And there are 85 anchors plus anchors across India, which has been deployed as part of the project. Next 400 anchor deployment is in pipeline, which is going to be deployed. And around 180 community members from across academia and industry, which are contributing to the source code of it. It's completely open source, interoperable source code. You'll see this anchor network. These remote measurement networks are in different locations. You will see this green and the orange part of it. The orange is IPv4 networks, and the green one is, orange is the IPv6 network, and the green one is IPv4 network. So in a way, we can immediately distinguish that how the last mile connectivity right now in the part of it. These are the 5 Anycast instances, and that makes it a completely different measurement network, where we can measure from where your services are being delivered, or there is any routing detour or not. Because maybe a possibility right now that all the major wave service are being served from CDN networks and Anycast networks. But where from actually your users are getting served, whether your recursive DNS and authoritative DNS, they are being served from your locality or not, or whether there is a more latency to it or not. So these are some of the use cases that we are working on, and we are adding every day new use cases on this. Like I said, that AIORI.in, whenever you go into that website, it will see, it will give you that from Bangalore, like I was serving from Kolkata, and in Kolkata, we have an implementation of this, but I've been served from Bangalore, and the latency was kind of 56.69 ms, but Mumbai was the minimum latency. But again, it was also there in Kolkata, and that was having a 64.93 latency. Now this measurement platform can give us understanding of what could be the peering infrastructure and how these ISPs are peering with each other. One of the things that, because these anchors are based on distributed computing paradigm, we have used nats.io. Each anchor is edge compute node, which can talk to other network, other instance over there. So we are having DSCP and static IP, where from we are actually putting anchors. So from one anchor to another anchor, we can also take a trace route and understand that whether these two anchors are connected through local connectivity, or they are going and there is some routing detour that is happening. So service latency also, you'll go to AIORI.in and just give your web interface, whether it is an IP address, whether it is anything that you wanted to search. It works on ICMP and HTTP. Whether ICMP fails, it go for HTTP, and it will give you what are the latencies from different areas. So if you are serving a website, or you are a organization which wants that from this particular region, customers should be served very fast, then like see, we have categorized it into green, orange, and other colors, that where from actually how is the latency of your web services. This is something which you can access. DNS resiliency from user endpoint. Each and every anchor is actually a DNS resolver, a recursive resolver. So from any of the anchor point, you can see that what is the DNS resolution from there, it will give you an understanding of whether a web service is impacting from its hosting provider or from the DNS providers itself. Like it's from Guwahati Anchor, I'm just trying to measure. So the root server latency is this, then the gob.in latency, then the miti.gob.in latency. So in a way, it will give you an insight that where actually your authoritative zones should be, and maybe it is also being a barrier. Now, this particular latency and everything measurement can be done by the user itself. So aiori.in, you can go log in into the website. You can start measuring yourself. And we have done a gamification over here. Again, the same thing that we have used, like you will have points. You just redeem your points whenever anybody is measuring from your devices, you are getting points. And whenever you are measuring from others' devices, you lose points. So in that way, the gamification has been done. The beauty of this platform is a new protocol, if you want to measure, it takes us around 2 to 3 weeks of time. Second, if any academic researcher wants to include any new protocol parameters over here, it's very easy. We can bring it on board, and we have a complete Git and CI/CD pipeline. It takes very less time for the development, and we can go ahead with that. Some of the tools that we have integrated as part of this project is DNSSEC Visualizer. You go and just give it the zone files, and it will visualize the DNSSEC, and it will give you report that what are the challenges with the DNSSEC and what actions you need to take care in order to provide DNSSEC capabilities in your zone files. So in the kind of tools, you can integrate any kind of, endless possibilities over here. Some of the things that we are working, like RSEC, they say that 13 root server out of 13, if you have 8 root servers for a particular location, then you have root zone resiliency. We are trying to understand from a point of time, whether from any geographic location, how many root servers are accessible and with a permissible latency. So we are trying to figure out more knowledge from these data points. Maybe from next conference onwards, we will be presenting the data points from this particular platform. Some of the use cases, and this is what you will get whenever you will be logging into the system. And all the query lists are over here. Right now, we are having ping, traceroute, and DNS query, and we're integrating others also. Thanks. I think I'm done. Okay, any questions? Thank you.
Sorry, I feel like I'm the only one asking questions here. So the tool is pretty good. With regards to the latency, can you specify the path that packets took if it is using ICMP or HTTP?
Yes, sure. So the traceroute that we are running inside the networks that tell us the path.
Is that actually the path, or because every session is different, right?
Yeah, definitely. Definitely, it will be different.
Yeah.
And we are trying to understand that what is the difference and how it is measuring.
Right.
So yeah, go ahead.
Can you go back to the previous slide? The measurement tool didn't show. Sorry, go back to the tool, the measurement tool. Yeah. So what are some of the things that you can measure? Just latency, or with regards to the loading of a specific website, or?
See, the first one is on the ICMP part, we are measuring the latency of it. Simple ping command.
Right.
Now, for traceroutes also, we can have traceroute from one location to another location and trying to get that path over there.
All right, right. But
yeah, one of the things that come up from here is in between those things, we are using some more measurements because some of the routes, their ICMP is blocked. So we are finding out more solutions towards that. And the IP addresses which we are finding in the path, the geolocation is not correct.
Yeah.
So now what we are finding right now, because we are having n number of anchors, we are using a triangulation method. And because we know the exact geolocation of those anchors, we are trying to get that the IP location from there where it is broadcasted.
Right.
So in that way, there is another research that we can go forward for the accurate geolocation of IP addresses from where it is coming.
Based on the address space.
Yeah. So these are something that is coming out of the research and the studies that we are going.
It's a pretty interesting tool. I developed a tool similar to you guys as well.
Oh,
Pretty.
thank you.
Thanks.
Okay, looking forward for the more contributions. Thank you. Yeah.
You have time? Hi, this is Dhruv. You did mention that like you are doing both on V4 and V6. Is there any difference that you have seen, any data point that you would like to share, something interesting in your measurement that came up?
Yeah, so we last 2 years we have been building on these data points. We have data points. So like you have said about the IPv4 and IPv6, definitely I can share you the interesting points towards there. So maybe I can mail you too.
And just final question, you at the start of the presentation, we mentioned about the RIPE project. So what is the difference? And in the sense that, like, there were reasons that you feel like you need to develop something indigenous and by your own. So what were those, and how are we going to make sure that, like, the same problem doesn't happen in this development, so that whatever you wanted as a features for any measurement protocol are being supported by this thing that we are being developing?
Sure. So the first thing that whenever we have started with RIPE, so there are very less deployments in India. So you will see around majority of percentage is not working. Second is, if you wanted to have more protocols into this, it is very cumbersome to add new protocol parameter for measurement. It takes longer period of time because it gets for community review and all that sort. So we have seen that there is a lacuna over there, because we wanted to have something which is coming out. And one more thing that was very important is, from our reason, there is very less understanding of how to measure things, how to work on internet protocol parameters, and how to understand things, how it works. The fourth thing that was that we wanted to also work on anycast networks, on DNS part of it, how DNS anycast work and how actually it is being measured, because you will see the root servers there, anycast instances are there, and we wanted to understand that how it is working and how we can measure those instances. The fourth one is we wanted to have a test bed which is available for academia. So anyone who is interested in this, we can provision a VM in our test bed, which is a completely a private cloud, and it can be in other academic networks also, and then they can make use of it. So it is very intuitive, and the best part was the interoperability. So here all the APIs are, all the modules are API driven internally, microservices environment. So each and every module, anybody could lease an anchor. So if organization 1 wants to lease the same anchor, organization 2 also can lease an anchor. So it is completely driven on pub sub model. So in that way, what happens, we have tried to get the next generation innovations into this platform so that it could be protocol agnostic and we can work on different layers. So these were some of the things that were there. Hope it has answered your question. Thank you.
Tobias Wiebig, Max Planck Institute for Informatics. You say protocol agnostic, which makes me wonder, wouldn't it be an idea to try to federate with other platforms like the RIPE Atlas project, for example? So is that something you're looking at? Like, how can you make them interoperate?
Sure. So that was one of the things that we have thought, that whenever if we wanted to interoperate with RIPE and CC or QIDA and others, even for APNIC measurement also, because if we can interoperate, then definitely new insights will come up. So that's one of the features that is inbuilt in the system.
Yeah, totally agree with you. The Atlas, the RIPE protocol, I tried the whole architecture myself, really can't figure out how to modify it based on my needs. So what you're doing is really good. So by developing it yourself, you have control over the sockets, the TCP or UDP sockets that you're using. So that way you can measure whatever you want to measure.
Yes.
Yeah.
Thank you.
Thank you. Thank you. We have Ms. Aisha Iftikhar. She's an APNIC fellow. Please give her a warm welcome.
Hi, everyone. My name is Aisha Iftikhar. I am presenting here as an APNIC 54 fellow. Besides, I'm, oh, thank you. So nice. So my name is Aisha Iftikhar. I'm here as an APNIC fellow attending this whole conference and all those training workshops. So basically, I'm serving as a faculty member in a public sector university in Pakistan, and I'm actually a cybersecurity researcher and activist. So I want to talk about the much hyped topic today, that is Web 3.0. You know, we have been listening to these fancy discussions over fancy discussions around cryptos and NFTs, and you know how we are going to make millions out of it, and what is actually metaverse and how you can have a really immersive sort of experience with it. But while we are transitioning from Web 2.0 to 3.0, it is really important to see is if it's worth taking the journey or not. So with this, I think, all right. So let's talk about Web 1.0. That was, I think, the static web that was actually evolved with the, you know, throughout those institutions, and ARPANET that actually became famous, and that was actually adopted as an internet, right? And that was basically the idea behind Web 1.0 was to have static web pages. Most of the content was actually based on text, and the only you know, sort of interactive, the only sort of, you know, multimedia experience that it was basically based upon was sort of animated videos and all that. So from Web 1.0, with the, you know, with all the, you know, adoption of internet, we actually moved to Web 2.0 that we are actually using today. You know, all that, you know, sort of interaction with Facebook, with, you know, Twitter, with Instagram, where we can interact with each other, where we can share data with each other. So Web 2.0 is more of user-centric, right? Where users can interact with each other and sort of generate their own content, right? So this Web 2.0 is much more interactive and much more there is much more content in Web 2.0 as compared to Web 1.0. So now after Web 2.0, we are now in a stage where we are actually transitioning to Web 3.0. So Web 3.0 is actually a new generation of web where it is actually under, currently it's just under, you know, sort of corporate discussions, right? So the correct or the exact definition of Web 3.0 has not, I mean, come to to the research community, has not come to a very exact definition of Web 3.0 yet, because the underlying technologies upon which it is actually based, they are actually yet to evolve and they are being developed now. So this Web 3.0 can be viewed as an enormous giant database, right? Where every website, every browser can actually use all of the internet's resources. And then it is basically totally decentralized. And that is actually powered by artificial intelligence, highly powered by artificial intelligence, blockchain. And, you know, it is the second name of the semantic web. So this is just to give an idea. If you see within Web 1.0, this was sort of very simple and static. Then we moved to this, you know, sort of user-centric content. But for the Web 2.0, actually, it is actually governed and actually regulated by the tech giants. Normally, you know, you see, you know, Google and Twitter and Facebook, right? So for the Web 2.0, actually, all the data that we share, or all the interaction that users actually have with each other, or for sharing any network or generating any content, everything is basically governed by these tech giants. So users soft off in Web 2.0, they're sort of of dependent on these, tech giants or technology providers actually who actually use high tech technologies for the, provisioning and regulation of the overall of the internet. Then the idea behind Web 3.0 is basically to have, it's basically a P2P decentralized actually technology where we do not need any sort of, central or, any trusted third party entity. So the Web 3.0 basically operates on two principles. The first one is it's trustless, and the second one is permissionless. By means of, what I actually mean by trustless is basically you do not need any trusted third party over here to actually interact with each other. If you see the decentralized applications or users, they can directly interact with each other. You do not need to have any sort of tech giant or anybody in between to have the interaction. The second thing is permissionless. In order to join the Web 3.0, any entity can join it directly. You do not need to have any permissions or anything like that. So this is basically, it actually operates on certain layers of database and decentralized applications to actually make it work. Web 3.0, and it is sort of very complex if we compare it with Web 2.0. So I'll just skim towards the tax because we are thinking it as a very fancy sort of transition. So I would like to highlight a few of the security aspects that are very critical to discuss while we are making this transaction actually. So decentralization, we are very excited about that. So everything will be decentralized, but we have to think it's a power or it's going to be a terrible change, because with decentralization it's not easy to manage and actually trace each and every identity over the internet, over whatever is going on. Then disinformation and data manipulation. So disinformation has been a really critical issue in Web 2.0 as well. But with Web 3.0, since it's going to be AI powered, and anybody can do anything, so it's sort of very difficult to actually control how we are going to handle this disinformation issue. Then obviously it is actually going to be a new platform for enhanced spam. There are so many identity risks because everything is anonymous, right? It's very difficult to actually control or to actually look or trace down people or threat actors when it comes to the identity. Then there are so many crypto attacks, so I won't be going into the detail of those crypto attacks. And then since it is based on decentralization, and you do not need to have any third party in between, so it's actually difficult to trace the people, and it actually leads overall to those anonymity issues actually, where you do not know who is doing what and who is posting what, and who is, how the internet is actually going to be involved with all that disinformation issues. And then since organizations are really looking forward to move to Web 3.0, so it's important to actually notice what risks will new businesses will going to have with this new technology adoption, because we are still living in an era, as we have noticed after COVID, that the cost of data breaches has enormously increased. So the next challenge is security adoption. Since the underlying technologies that actually govern the Web 3.0 are still under development, and they are still going to evolve. And overall, the structure of Web 3.0 is really complex. So if something goes wrong in Web 3.0, it is really very complex to fix that issue. First to figure out that issue, and then next to fix that issue. So the approach that we are currently using with Web 2.0 is basically that you have to figure out an attack, and then you have to be responsive and do something about it, right? Incident response. But in Web 2.0, this is not going to work, right? Because it is really complex, and it's really difficult to fix the issues if something goes wrong with the system. And the last point that I want to figure out is challenges that are actually associated with compliance and regulations. So with this adoption, we are going to see a whole new landscape of maybe money laundering and terrorism, right? Cyber terrorism, because, the overall structure of the Web 3.0 is actually really supportive for all these activities. So if I would be concluding my topic, it will be like, although we are very excited to go to this transition and take this journey, but we do not know what's at the other side of the picture. We don't know if it's really worth taking this journey or not. So with that, I would like to conclude my presentation. Thank you to all of you. So oh yes, there is one graph as well. So I got this sort of data from Juniper Research. It's it's still 2020. So if you see the cost of, the data breaches cost has reached till 2020, it was still 3 million. But according to the IBM's data breach report that they published in 2021, I just couldn't find that graph with me right now. So that the new, according to the new statistics, in 2022, it has reached to $6 trillion. After COVID, the statistics for data breaches and the overall cost, that is, it has actually, the overall count has reached to $6 trillion. So if with this, with this trend, with this number count, you can see how risky if it's going to be if we are transitioning to Web 3.0 without any sort of standard procedures, tools, and we need to work and talk about it more openly and more responsibly if we are going to make this transition. So I'm done with my presentation. Thank you for listening. So if anybody has any questions.
Yeah, thank you. For records, it's Anand Raje from my iPhone. One of the major issues using Web 3.0 is working with the infrastructure providers. So what are your takes of Alchemy and other infrastructure providers, and what are the security hazards over there?
Okay, so new companies are, it's good that there are a few companies that are taking this problem really seriously, and they are still working in to introduce new infrastructure and things like that. But the problem is we actually need a standard, a whole new set of protocols, a whole new set of infrastructure, because the technology and the principles over which Web 3.0 is operating, actually it's totally different, and it still need to be evolved. So I think it needs a lot of, this research is still going on. So I think we do not know it is actually going to be concluded in terms of infrastructure and the new protocols that we will actually have by end of this transition. So because this technology is still at the enterprise level, it is just being discussed at the enterprise level. So a lot of work is actually needed and actually going on in terms of infrastructure and protocols and all that.
Thank you, Aisha.
Thank you. Thank you very much.
Thank you. Our fourth talk today is Ms. Afifa Abbas. You would have seen her before on the routing SIG. She's going to talk about how we have been helping hackers break into our systems, right? We've been making life easy for hackers. So it's all our fault.
Do I need this podium? Good afternoon, everybody. Thank you so much for attending this session. Welcome to the lightning talk of APNIC 54. My name is Afifa Abbas. So my presentation starts with a mysterious question, and that is, are we making the life of a hacker easy? So throughout the presentation, I'll be eventually reveal the answer. So my presentation will be based on the best practices. So on the first slide, I would like to demonstrate two images. And one is a wall that is a rock solid wall, and another has a huge crack in it. Now the question is, if I personally ask somebody, if you have to put all the valuables behind a wall, which one would you choose? Without given a second thought, all of you would go for the wall that has a rock solid structure. Because if you go for the other one, that means that is accessible by everybody. All your valuables will get stolen. Right. So if we look back, the major cyber attacks that are going on worldwide, none of the attack took place for not having enough tools, for not having enough resources, for not having enough monitoring system, but most of them took place by not following the best practices, by not sticking into the basics. So the question remains, who creates this sort of cracks? Is it always the cyber attackers? And the answer is no. Cyber attackers only access those for the things that we let them to access, right? The things that we make available for them. So moving on to the next slide, in my talk, I'll be discussing about that we have some sort of a misconfiguration. We have the tendency to falling for the traps. We have the disbelief and misconception and myths going around that the cyber attackers take the advantage of, and we all become the victim. And in other words, we call it the leaks in the bucket. So I will be discussing what are the leaks in the bucket that is causing the huge cyber attacks worldwide. So we all here, we all belong, all of we are sitting here, we all belong to a particular company, and the company is a part of the network. So when we bring out any device and before integrating it within our network, they have a default credential. It can be from any vendor. So even after integrating that particular device within our network, we tend to not changing it at all for decades. So back in 2019, I was part of a huge security check in our organization. And it turned out that few of the major devices did not use any complex passwords. They were having the very simple one. But when I detected it and when I let the team know about it, their reaction was, you know what, we are doing the UAT. And if we use the complex passwords, it will delay out the UAT further. So that was the ridiculous excuse I have ever heard. At the same time, exposing the blacklisted ports that we all know. So when I was very new in the cyber security industry, I did not understand why we cannot expose the blacklisted ports in the internet. But then again, I took, just to convince myself and comfort myself what actually happens behind the scene, I took the Wireshark tool and I tested with one of the protocols, and I could see my own credential in plain text. That was quite scary, and that changed my entire perspective and also made me even more passionate for cybersecurity. We all have this perimeter network, right? So in our in most of the organizations I have seen in our country or within the region, the management, they don't tend to move or make any changes to the perimeter devices because all the important links, all the MFS links, all the VPNs, everything is connected to that particular device. And they are very much reluctant to make any changes with the fear that if I put any changes or make any changes, there is a possibility that my device may not get up. But what they tend to forget that it can equally be fearful for any sort of an external cyber attack, but they took it for granted that it will never happen to them. Moving on, we all have this, like we all use mobile phone. We use so many apps in our mobile phone. So once in a while you get this pop-up that, you know, you need to upgrade this particular software, but we ignore. Updating a software doesn't always mean that you are introducing a new feature, but it also means that you are having new security updates, right? Back last year, when it was a lockdown in our country, so in the middle of the midnight, I was working with my team troubleshooting one network incident. So one of the team members from external third party, they said that, and the management team was also involved on that particular meeting, it was causing a revenue loss. And he said that without investigating much, he came out with the conclusion that the issue took place because the logging was enabled and the device couldn't take the load of the logs, and immediately he decided to stop it. But then again, my question was, if it occurs again, how are you going to decide without the loggings enabled that what was the root cause? And this issue kept on happening again and again because we did not fix the root cause, but we fixed something else, which was actually not the reason behind it. During the pandemic, we all used our office network. We all used our home routers, right? And it turned out that in my home router, so many neighbors were connected, right? And I did not know that out of this neighbor, was there any hacker or not? There could be, right? They have this possibility to, sniff my packet because I was doing all my monetary transaction from home using that router. So these are the few cybersecurity traps. I'm not going to go into detail with it, but I'm going to discuss about some cybersecurity myths and misconception that with sophisticated tools in place, we are safe. The thing is that all the tools are having their own limitation. We have to know what are those limitations and how can we back it up with other technologies. We perform penetration testings, that's great, but we always need to have the third eye view. Internet-facing applications are great to implement, great to secure, but at the same time, we need to know how to secure the inside network. There are people who say we never experience cyber attacks, and so our security posture is strong. Cybersecurity is all about attitude and lifestyle. So if our attitude is positive, we have to change this perception as well. I would like to draw one real example regarding cyber threats come from external attacks. So the motivation can come from anywhere. I would like to draw here one real life example that one 12-year-old boy in USA, he ordered one pizza. He was supposed to get the pizza within 30 minutes, but it got delayed 30 more minutes. And he decided to take the pizza company's website down. So that motivation came from there, but the motivation can turn into a reality when we will keep these leaks open for them. Third-party security provides, we are too much depending on the third party. The thing is that being an insider, we know our architecture and traffic flow better than anybody. It's always good to take any help from the third party, but it's not entirely good to rely on them entirely. Security is the responsibility of the security department. Yes, we can always help, but the thing is that if we put a lot of technology, but at the end of the day, if you click on a phishing email, then the security team won't be able to come and save you. It is everybody's responsibility. So the takeaway would be misconfigurations need to be fixed. We need to watch out for the traps, get away from the cybersecurity false beliefs, and follow the best practices. I'm a huge advocate for fixing the basics. So in a conference like APNIC, we talk about rosy technologies, which I absolutely appreciate, but we also tend to underestimate the power of the best practices. So answering back to my question, are we making the life of a hacker easy? So the answer would be yes to some extent, but can we still fix it? The answer is yes again. Thank you so much.
Thank you. Okay, we have only 4 items listed on agenda, but APNIC is feeling generous, so we get a bonus talk. And I won't bother introducing Aftab. If you don't know what he does, please meet me later to have your APNIC and Internet Society membership cancelled.
All right. Hello, everyone. Aftab here. I'm not going to spend time on explaining myself. I'm not asking a rhetorical question. So do we still need IRR or not? Well, I don't know if it is rhetorical or not. I literally have 6 minutes. Either I can speak very fast or I can just explain things easier and take 5 minutes from Toyama-san, who will be coming here, or he's still here. I don't know. Anyway, let's start. So let me explain. I work for Internet Society. We received resources from APNIC last year. Well, it was pandemic. We said, well, get something from APNIC before it runs out. We got our resources from APNIC, and we said, oh, everything is fine. We do the right things. We created the route objects. We created the ROA. Perfect. These are the snapshots of that. We got it in 2021 in February. And of course, we took some time and created the route objects and the ROAs, right things. Perfect. And if you can see from the RIPE stats that we started advertising it, we advertised 1/24 from Sydney, where I have a lab, and another one from Zurich, where my colleague Max has a lab as well. So this is how we are connected. In Sydney, we are connected to IX Australia Sydney node, and we are also connected to, well, quite interestingly, in Georgia Tbilisi as well. So Hurricane Electric can show you the path. So it's pretty nice, everything cool. And then something happened. All of a sudden, we looked up and say, well, there's a route object. Who created that? We didn't. They are not announcing it. So we looked it up. It's an RADB entry. If you don't know about RADB, RADB is a IRR database, Internet Routing Registry database, maintained by a company called Merit. They mirror around 40 odd IRR databases from across the globe. So it's a collection of databases, plus they have their own database. So our route objects end up in RADB with a different origin AS. We have no relationship with that AS. And it was created by someone we have absolutely no relationship with. We do not buy a transit from them. We do not peer with them. And it just ended up there. So that triggered something. That was the problem, because then it is susceptible to route hijack. We said, okay, fine, let's look at the data, why it is happening and how much bigger the problem it is. So remember, the whole BGP and everything is an honor system. You have to trust each other because we rely on the information, we rely on the data which is based on RADB and RPKI. RPKI, we are still at 40%. So mostly it's like 80–90% is IRR databases. So we have to rely on that. And we have to trust each other. And that rhetorical picture is there, which can help you understand how the whole internet works. Now, moving forward. So we started investigating. There are 3 of us, myself, my 2 colleagues, Max and Amrish, in different parts of the world. We started collecting data, and we have some good news for you. Well, we are not that old, but still looks like that. We collected the data and converted it to something which everybody likes, not the hero, but the JSON. So the data is available on the link, which I'm going to share right now with you, right at the end. So you have to wait for us. We only looked up the APNIC resources right now for this slide. I presented this at OSNOG 2 weeks ago. So it's predominantly for Australia and New Zealand, but you will find some gems in it from the region as well. So what we were doing is once APNIC allocates, this part I'm going to speak very slowly. When APNIC allocates a resource, for example, for an IPv4, if they allocate a /22, you will find exact matches of a /22 in RADB. And if someone is announcing more specifics of that /22, for example, a /24, a /23, you will find those as well. So we started looking at the data that how many exact matches of the allocations are in the RADB and how many more specifics are there. In the APNIC, the situation is really very bad. If you look at the number, there are 4 categories: status 1, status 2, status 3, and status 4. What these statuses mentioned here. Status 4 is the most problematic part, where are more specifics, and there are in thousands. So this is how the data looks like. If you know how to handle JSON, it's really piece of cake. You can download the data from the link I'll provide at the end, and you can parse yourself, put your ASN or maintainer in it, and see how much data you have created, how many route objects you have created in the RADB database. So this is how it is. In it started gradually increasing. I don't know what happened in 2012 and 2018. There is a massive hike in route object creations. And mostly they are not created by the custodians or the resource holders. They are created by third party. These are called proxy objects. Why? Absolutely no idea. Same is the case for the exact match and more specific in other statuses. Same is the case. 2020, something magical happened. There are not many objects in that category, still 1,500. But if you look at the last one, which is status 3, more specific, there are more than 25,000 route objects just in 1 year in 2017. And this is only APNIC data. Who are the people? Who are the creators? Not the people. There are organizations behind these objects. So who are creating that objects? For example, on top is nobody at aapt.com.au, literally nobody at aapt.com.au. Then there is China Mobile, Hutch City, HGC. Hutch City and HGC is the same company, Hutchison. Then moves on to PACnet. PACnet doesn't exist anymore. Probably Terry knows that very well. It's acquired by somebody else. Then AMIX. AMIX exists in probably every RIR, and that is the most problematic part. And there's a list. Same goes with the more specific ones. Again, hgc.com.hk, they are creating more than 100,000 objects for others, not for themselves, for others. Don't know why. For example, we picked a few prefixes. For example, 120.29.54.0/NIM4 has 32 route objects. Why? No idea. Here's the case, multiples up to 20, 30 objects for one prefix. Every object has a different origin AS. Remember, you are creating prefix filters on the basis of this data, how vulnerable it is. Same is the case with status 1, which is exact. APNIC allocated a resource to someone, a third party created a route object for that resource with a fourth party origin AS. Absolutely bizarre. Then we started looking at when they created those objects. So the date is also there, so you can have a look, then when it appeared. So what we have seen is you started peering with someone, they created an object, you end up moving from that peer and started peering with somebody else, nobody deleted that object. So that object still exists. So people are creating it, no one is deleting it. It started from 2012, ending up in 2020, starting in 1999, and then latest object created in 2021. So it's been happening for like 2 decades. So again, most important thing is who's on top of it, who's creating the most object. At least this data is for Australia. If you are interested in your country, happy to give you this information about your country or your network operator as well. I can do it quite quickly if you're interested. For example, IPNOC at PACnet has created 897 distinct origin ASN record. 897 distinct origin AS. Just imagine that. Same is the case with PACnet on this specific one, 470. That's a lot of them. So again, is if you understand the 4-byte ASN private range, I don't know if someone can explain why this object exists. It should not be there at all. These are private ASNs and a /28. IPv6 is not that bad. That is the biggest relief. But because it's not being used that heavily, that's why. It will be there soon. So it's still, there are some objects, but it's not really as compared to what is happening on the v4 side. Going quickly, the problem is we are asking you to filter on the basis of some sort of data. Either it is IRR or RPKI. If RPKI is only 40%, then you have to rely on the IRR. If you're relying on IRR only, well, that's the problem. So if you're interested in the data, The data is available here. We run it every 15 days. So we have a time series. We have done it 4 times only, but we will be doing a time series data so that it will be available. It's all public information. We are not creating anything new, but it is just in JSON, so it's easy to parse. So if you are interested, please have a look, find more data points. If you are interested in the reporting of your country or your particular maintainer ASN, you can reach out to me. That's all from my end. Thank you so much.
I won't ask for questions because that will take us the rest of the evening. I think many of us who operate networks have suffered at PAC. Speaking personally, I've been trying for more than 10 years, since 2007, to get PACnet to delete my RADB, because once we use them as transit. Please catch him later. We are a little running over time, and the BOF is supposed to, I believe, take this room. Yeah. So thank you to the speakers. Thank you for your talks, and hope to see longer presentations and more detailed at APNIC, which is in Manila, in a few months' time, by which time I hope you'd have much more data and something more in depth and use up a full 40-minute slot. Thank you.
That I found, oh, she's mine. Oh, check out that. Let's just take it slowly. Would you know, don't take that and go. Say, oh, go,